Have you ever used a 3D printer? Have you ever wondered how 3D filament is made? With the increased affordability of 3D printers, they have become household objects used to make a variety of things from toys to tools. 3D filament can be made from a variety of materials such as PLA, ABS, and PET. Here at Ecospool, we are committed to preserving the planet by recycling plastic bottles into PET filament.
Our cell consists of 6 main stations: bottle processing, shredding, drying, extruding, spooling, and packaging.
The first step of the manufacturing process is bottle processing. The bottles are placed on a conveyor that leads to a cleated conveyor that conveys the bottles into a hopper located inside the cell. From the hopper, the bottles are singulated and placed onto a pallet that will ferry it through the remaining stations. At the first station, the bottle cap is removed and a locator is added to keep the bottle shape and aid in manufacturing. The second stage removes the label from the bottle with a pair of pincers. The third stage uses 2 saws to cut the ring left behind from the cap, and a blast of air removes it from the bottle. The bottle is then inspected with a camera to ensure the label and ring are removed. The fourth stage grips the bottle and retrieves the locator added in the first step to be reused. The last step determines if the bottle is good or bad based on the photo taken in stage 3. If bad, the bottle is disposed of. If good, is carried by the servo gantry robot to the washing station. After 5 bottles are loaded into the washer, they are grabbed by a tool that carries them through a deluge of chemical solvent and grit to clean the glue from the bottle. In the bottom corner is an example of the industrial computer program that controls the movement of tools, pumps, and cylinders being operated in the washer. The entirety of bottle processing and shredding are controlled by a Siemens programmable logic controller. After the bottles are cleaned, they are rinsed and dried in the second washing station. What started as a bottle from the local recycling program is now cleaned raw material for the shredder.
As the processed bottles exit the final stage of the washing station, they fall onto a cleated conveyor by means of a gravity-fed slide. The conveyor deposits these bottles into the hopper of the shredding station. A Siemens PLC monitors the shredder as it processes the bottles through the 2 independent sets of teeth and checks for potential jams and overflow scenarios. The upper set of teeth is designed to break up these bottles into 5mm chunks, while the lower set is designed to further break up said chunks to the targeted specification for the extruder. The resulting 3mm granulated PET material is then sent to drying through the vacuum transfer system in regular time pulses dictated by the PLC. The drying station is responsible for removing all the moisture content present inside the particles. The dryer consists of 6 phases and are displayed and monitored by the PLC and HMI. In phase 1, the particles from the shredding station are continuously stored as they arrive from the vacuum transfer system. As for phase 2, a hopper with an integrated vacuum transfer unit moves the particulates from the storage silo to the in-feed hopper, and then into the heating chamber. During phase 3, the particles are preheated to a temperature of 180 degrees Celsius. Later, the heat is reduced and maintained to 120 degrees Celsius for approximately 25 minutes. This allows the water molecules that were hydroscopically infused in the PET granules to form water vapor. The particles then transfer down into the vacuuming chamber. In Phase 4, the particulates are enclosed inside the vacuum chamber using pressure-sealed sliding shutters. A powerful vacuum is applied to drop the pressure within the chamber to less than approximately 0.01 millimercury. This process will boil away any lingering moisture within the particulates. During Phase 5, the moisture-free PET particulates drop freely through the outlet. And during the final phase, the particulates are vacuum transferred to the final storage silo for the extruder to access. A full suite of monitoring windows and manual controls are available to operators via the HMI when troubleshooting, maintaining the machine, and ensuring the quality of the product PET material.
PET regrind is added to the main hopper from the dryer. As the PET moves down the hopper, it is mixed with a colored additive. The mixture then moves into the extruder, where the screw moves the mix down the length of the barrel while heating it up to 245 degrees Celsius. Once the molten mixture reaches the end, it is forced out through the nozzle and passed on to the spooling station. After exiting the extruder, the molten filament is air-cooled through a series of fans. A vision camera is used at the beginning of spooling station to inspect the filament for defects such as bubbling, burning, bulging, necking, and tolerancing. Filament exiting the cooling chamber is solid enough for the feeding wheels to pull filament through. The rate of the feeding wheels must match the rate of extrusion so that the filament forms a straight, consistent strand in the cooling station. Filament is wound through the tensioner and spun onto the spool by the spooler. Since the extruder never stops extruding, the tensioner's purpose is to maintain a reservoir of filament when spooling is stopped and completed spools of filament are swapped out. After 5 meters of filament is spun, the robot places the filament at a cutting station where it is cut and held in place. Then the ABB robot secures the lagging strand of filament into a clip on the spool. The finished spool is then indexed to the other side, where a Fanuc robot places it into a bagging station. The Fanuc robot places a fresh empty spool onto the spooler, ready to be swapped out when the next spool is completed. The ABB robot initiates the spooling process by taking the leading strand of filament from the holding station and securing it into an insertion hole at the center of the empty spool.
The packaging process starts with heat sealing the bottom of the vacuum bag. Disclaimer: some assemblies will be hidden as needed for better visibility of demonstration. Pneumatic grippers feed the vacuum seal roll upwards and suction is used to open the bag. A desiccant packet is dispensed into the bag, followed by a robot dropping off the finished spool from the spooling station. Next, after a vision inspection to confirm the spool is in place, the bottom of the bag is cut through. It is then transferred to be vacuum sealed. Vacuum sealing a 3D filament spool with desiccant is an integral step to prevent moisture from damaging the quality of the filament. After vacuum sealing the bag, it is released onto the conveyor. A gantry will pick up the packaged spool and drop it in a box. The box is considered full after 20 spools. The gantry access is sealed and the light curtains muted so that the operator can come in and unload the box.
and that is how regrind filament is made. Here at Ecospool, safety is an integral part of our process, which is why we use state-of-the-art safety featuring in our cell. Our cell has various stack lights located around the cell to ensure everyone is able to see what the state the cell is in and if it is running or not. All doors leading into the cell are interlocked doors that have a push to enter. This ensures the cell is shut down safely in order for someone to enter. In areas where an operator will need to come in close proximity to the cell while it is operating, we have light curtains to ensure that the operator can only access that part of the cell when it is safe to do so. The world consumes 1 million plastic bottles per minute, and it takes at least 450 years for one plastic bottle to decompose. Thus, recycling plastic is our effort to contribute towards environmental sustainability. With all of us doing our part, we can help preserve the planet. Thank you for watching, and we are Ecospool.